pi by 2. This we have. Now add pi by 4. Pi by 4 plus x by 2, pi by 4 plus pi by 4, pi by 2. Now the limit lies between minus pi by 2 to pi by 2. Therefore, tan inverse tan theta will be equal to theta. That is pi by 4 plus x by 2. Now the next is second part of this question. Prove that cot inverse square root of 1 plus sin x plus 1 minus sin x upon 1 plus sin x minus square root of 1 minus sin x is equals to x by 2. Limit lies between 0 to pi by 2. Now first solve this value 1 plus sin x. Instead of 1 cos square plus sin square x is equals to 1. But here angle is half. So cos square x by 2 plus sin square x by 2 sin 2x. 2 sin x and cos x. Angle is half, so here we divide the angle by 2. So that is equals to cos x by 2 plus sin x by 2 whole square. Similarly, for 1 minus sin x, that is equals to cos x minus 2 minus sin x by 2 whole square. Now put these value here. Cot inverse square root से square it will get cancelled, so we get it as cos x by 2 plus sin x by 2 plus cos of x by 2 minus sin of x by 2 upon cos of x by 2 plus sin x by 2 minus cos of x by 2 minus sin x by 2. Now the limit is this. If we take cos 0, cos x, cos pi by 2. Here angle is half. First divide the angle by 2. Pi by 4, 0. Cos 0 is 1. 1 is less than cos x by 2, less than 1 by root 2. Sin 0 is 0. Sin x by 2 less than sin pi by 4 also has value this. It means cos x by 2 is greater than 1. And sin x by 2 is greater than 0. So that is cos x by 2 is greater than sin x by 2. If it is greater, it means cos x by 2 minus sin x by 2, that is greater than 0. Cos x by 2 minus sin x by 2 is greater than 0. अगर वैल्यू greater than 0 है, we know modulus of x is equals to x if x is greater than 0 and minus x if x is less than 0. So we will use this. X is greater than 0. So cos x by 2 plus sin x by 2 plus cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2 minus cos x by 2 minus plus sin x by 2. Here sin will get cancelled, here cos will get cancelled. So cot inverse 2 cos x by 2 upon 2 sin x by 2. Cos upon sin is cot. So cot inverse and cot equals to theta. If angle lies between, when x by 2, this is pi by 4. So cot pi by 4 is 1. So angle limit lies between the given function. Therefore, the value is x by 2. Now the next one. first part of this. Prove that tan inverse square root of 1 plus cos of x plus square root of 1 minus cos of x, 1 plus cos x, 1 minus cos of x is equals to pi by 4 minus x by 2 if x lies between pi to 3 pi by 2. Now use the values here. 1 plus cos x, that is equals to 2 cos square. So square root of that plus root 2 sin x by 2 upon root 2 cos x by 2 minus root 2 sin x by 2. Square root of 2 common and it will get cancelled. Cos x by 2 common, 1 plus tan x by 2, 1 minus tan x by 2. From numerator and the denominator, take square root of 2 cos x by 2 common. Now 1 plus tan pi by 4 is 1. So we can write it as tan inverse tan pi by 4. But here the limit x lies between this. So angle x by 2, pi by 2, 3 pi by 4. Between the limit pi by 2 to 3 pi by 4. Here we write it as modulus of this. Because we have to check the limit, square root of 2 will get cancelled. Now between pi by 2 to 3 pi by 4. 3 pi by 4. 3 pi by 4. Angle is 135. So between pi by 2 to pi. Between pi by 2 to pi, sine is positive here, but cos is negative. So cos is negative and sine is positive. So minus cos x by 2 minus sine x by 2. Clear? Now take negative common, cos x by 2 common. So 1 minus tan x by 2, 1 plus tan x by 2. यही आया हमारे पास 1 minus and 1 plus. So instead of positive, negative sign here and positive here. So we get tan inverse tan pi by 4 minus x by 2. Pi by 4 minus x by 2. Tan inverse tan theta will be equal to theta if limit lies between minus pi by 2 to pi by 2. Now this is the term. If we write it as minus 3 by 4 less than minus x by 2 less than minus pi by 2. Add pi by 4. Pi by 4 minus 3 pi by 4 minus 2 pi by 4, that is minus pi by 2. Pi by 4 minus x by 2 minus, we have to add pi by 4. Pi by 4 minus pi by 2. Pi minus 2 pi minus pi by 4. So the limit lies between minus pi by 2 to pi by 2. Therefore tan inverse tan theta is equals to theta pi by 4 minus x by 2. Clear? Prove that cot inverse square root of 1 plus sin x plus square root of 1 minus sin x square root of 1 plus sin x minus square root of 1 minus sin x pi by 2 minus x by 2 if x lies between pi by 2 to pi. Now 1 plus sin x. Instead of 1 we can write cos square plus sin square. Angle is half here, so cos square x by 2 plus sin square x by 2. 2 sin 2x का फॉर्मूला यूज किया, 2 sin x cos x, एंगल इज हाफ, सो cos x by 2 plus sin x by 2 whole square. Similarly, for 1 minus sin x, cos x by 2 minus sin x by 2 whole square. Use this formula, we get cot inverse cos x by 2 plus sin x by 2 modulus plus cos of x by 2 minus sin of x by 2 upon cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2. Clear up to here? Now the limit is between pi by 2 to pi. Now angle here is x by 2. So what we get? Divided by 2, pi by 4, x by 2, pi by 2. Cos pi by 4, cos 90, sin pi by 4 and sin 90 is 1. Sin x by 2 is less than 1 and cos x by 2 is less than 0. It means cos x by 2 is less than sin x by 2, or we can say that this term is less than 0, and we know that modulus of x is f if x is greater than 0 and negative if x is less than 0. Since this value is less than 0, so this modulus will be negative. So cot inverse cos x by 2 plus sin x by 2 minus cos x by 2 minus sin x by 2 upon cos x by 2 plus sin x by 2 minus minus plus here cos x by 2 minus sin x by 2. Here sin will get cancelled and numerator cos will get cancelled. Sin plus sin, 2 sin x by 2, 2 cos x by 2. So cot inverse tan x by 2. Cot 90 minus theta is tan theta. So we can write it as cot pi by 2 minus x by 2. So the result is pi by 2 minus x by 2. If we write the limit minus x by 2 minus pi by 2 minus pi by 4, then add pi by 2, pi by 2, pi by 2 minus pi by 4, take the LCM, 2 pi minus pi, limit lies between 0 to pi by 4, therefore cot inverse cot is theta is equal to theta. Now the next is prove that tan inverse square root of 1 plus x minus 1 minus x, 1 plus x plus 1 minus x is equals to pi by 4 minus 1 by 2 cos inverse x, x lies between 0 to 1. अभी हमने जो भी क्वेश्चंस किए उसमें या तो यहाँ पे 1 प्लस कॉस था या साइन, 1 प्लस कॉस में था या 1 प्लस साइन में था. अब यहाँ पे हमारे पास x है तो हम फॉर्मूला यूज करते थे cos 2x का. सो पुट x इज इक्वल्स टू cos 2 थीटा here. Put x is equals to cos 2 theta. What we get? Tan inverse 1 plus cos 2 theta minus 1 minus cos 2 theta upon 1 plus cos 2 theta plus 1 minus cos 2 theta. Now 1 plus cos 2 theta will be equal to 2 cos square, 2 cos square theta minus 2 sin square upon 2 cos square minus plus 2 sin square theta. यही आया हमारे पास. Square root of 2 will get cancelled. So what we get? Tan inverse root upon 1 plus 10. 1 is the value of tan, pi by 4. So we can write it as tan pi by 4 minus x by 2. We can write it like this. Here we have theta, so theta here, pi by 4 minus theta. Now limit 0 to 1. So if we take tan here, tan x less than tan, 1 is the value for tan pi by 4. So tan x is, let it be theta. So 0 is less than theta, less than pi by 4. Or what we can say, what is the value of x is cos 2 theta. X is cos 2 theta, cos 0, cos inverse 0. Value of 1 cos 0 is 1. So we can write it as 1 less than theta, cos 1 is 0. Clear? Or not up to here. Zero is less than 2 theta, less than pi by 2. So 0 is less than theta, less than pi by 4. Now tan inverse tan theta will be equal to theta. Add pi by 4. So pi by 4 minus theta lies between minus pi by 2 to pi by 2. So tan inverse tan theta is equals to theta. And theta is equals to cos inverse x 1 by 2. So this is what we want to prove. Now second part, tan inverse square root of 1 plus x square plus 1 minus x square is equal to pi by 4 plus 1 by 2 cos inverse x square minus 1 less than x less than 1. आपने x को क्या पुट करना है, आपको यहाँ से भी अंदाजा हो सकता है. पुट दिस वैल्यू इक्वल टू थीटा, देन यू गेट x एज cos 2 थीटा. tan इनवर्स 1 प्लस cos 2 थीटा, पुट x स्क्वायर एज cos 2 थीटा हियर, 1 माइनस cos 2 थीटा, 1 plus cos 2 theta minus 1 minus cos 2 theta. So what we get? 1 plus cos 2 theta is cos theta plus root 2 sin theta, root 2 cos theta minus root 2 sin theta. Root 2 will get cancelled, cos theta take common. So 1 plus tan, 1 minus tan. So formula will be tan pi by 4 plus theta. Tan pi by 4 plus theta. Now minus 1 less than x less than 1. Squaring both sides. X square x square is equals to cos 2 theta. So theta lies between 0 to pi by 2. Cos 90 is 0 and cos 0 is 1. So theta is 0 to pi by 4. Now here we have pi by 4 plus theta. Add pi by 4. Pi by 4, pi by 4 plus theta. Pi by 4 plus pi by 4, pi by 2. Limit of tan lies between minus pi by 2 to pi by 2. So tan inverse tan theta is equals to theta. And value of theta is cos inverse x square 1 by 2. We can write it as cos inverse x square 2 theta, or theta is 1 by 2 cos inverse x square. Next one is simplify cos inverse 3 by 5 cos of x plus 4 by 5 sin of x. And second part is sin inverse 5 by 13 cos of x plus 12 by 13 sin of x. Now here